Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hi, everyone. Thank you for joining us for the next session of our RAG Hack, RAG on PostgreSQL. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It'll be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Pamela, Joshua, thank you so much for joining us.
Thank you, Anna. I'm Pamela. I'm a Python cloud advocate, and I'm joined by...
Hi, Joshua Johnson. I'm a product manager on Azure Database for Postgres.
Sweet. So we are going to be talking about how to build RAG with Postgres. And I'm going to be starting with just how to generally build RAG with Postgres and walking through a RAG with Azure Postgres repo that you can get started with yourself. And then Joshua is going to show us all these cool AI extensions specifically for Azure Postgres, where you can really optimize your RAG developer experience. So let's start off with simple RAG on Postgres. Now, you may have seen this diagram before if you've been joining us for a lot of our RAG hack streams, but this is generally what a RAG flow looks like. RAG stands for Retrieval Augmented Generation, and it is a technique that we can use to get an LLM to answer questions based off of our own database, right? So we start off with the user question. We use that user question to search our database for relevant information. Then we send the user question and those relevant bits of information to the LLM, and we get back an answer, and that answer has citations. So that is a simple RAG flow, and it's actually really, really powerful when you combine a great search with a great LLM. Now, for that search step, general best practice is to try to do a hybrid search with the user question. So a hybrid search means doing a combination of a vector search and a keyword search. A vector search is going to find us semantically similar things to the user question, which is going to find a lot of really good results. Keyword search is useful if the user is searching for something exact, like if they're looking for an email address or someone's exact first name, last name, right? That's where you want to have a full text keyword search. And then we want to combine those results together, fuse those results together to, rank all the results and have a fused result. So that is a hybrid search. And we're going to show how you can actually do that using Postgres. So if we look at this diagram again, if we're doing a simple RAG with a hybrid search, we get the user question. We then use an embedding model to compute a vector embedding for that user question. And we use both the vector embedding of that question and the original question in order to do a search on the database. And then we get back the results, and we send the results and the text question to the LLM and get back the answer. So now we see what the simple RAG flow looks like if we're doing a hybrid search, and we can see that there's more technology involved because now we need an embedding model as well as a large language model. So how do we do this with Postgres? So the first thing we need is that if we want to be able to do a vector search, we need support for vectors. Now, luckily, there's this amazing extension from the community called pgvector, and it's really easy to install locally. It's also easy to enable on Azure. And if you want to get started with it, you can go to the pgvector repo and follow the guidelines there. You can also look at our documentation on Azure to how to get started on Azure. I also have this pgvector playground that I use when I want to play around with it, that sets it all up for you inside a GitHub code space. So that's actually what I'm going to use here. So let's actually just step through this. All right. So I have this this pgvector playground that sets up Postgres plus pgvector. And it does that by bringing in the Docker image. So there is, if you know about Docker, there is a Docker image specifically for pgvector, which will bring in both the most recent Postgres 16, and then also bring in the pgvector extension and set it up. So that's one way that locally you can get pgvector running. And so that's got that set up. So now I've got access to pgvector and Postgres, and it's all running locally. So then I can set up my pgvector extension. So here I've got some Python scripts that set it up. You could, also just do this in straight SQL or in your language of choice. But what you can see is that I connect to the database, right? And so here I'm just connecting to the local database. And the first thing I want to do is say create extension if not exists vector. So this will initialize the vector extension in this database so that I can actually use it. Then I'm going to create a table that uses the vector column that comes from that extension. So you can see here, this creates a table that has a column named embedding, and it has a vector column in it that has a length of 3. So whenever we talk about vector embeddings, every model produces embeddings of different lengths. So in this example, where it's a list of floating point numbers. So this is just going to be a list of 3 numbers. Typically, the actual models that you're going to work with are going to have lengths between 256, maybe even up into the 3000s. So that creates a table. And then if I want efficient search of the vectors in that table, I need to create an index. And there's actually a few different index algorithms you can use. Here I'm using HNSW, which stands for hierarchical, so hard to say, navigable small worlds, HNSW. So this is a particular algorithm that will do approximate search for vectors, and which is very efficient and has shown to have really, generally really good results. So I'm going to say, make an index using HNSW on that column. So that way, every time I do a search on this column, it's going to actually use that efficient HNSW index. Now, to test this out, I can insert a bunch of vectors here. So you can see I actually insert a bunch of NumPy arrays. That's the data type that I have to use in Python. But generally, we're inserting lists of floating point numbers, right? So I insert a bunch of floating point numbers. And then I can start doing searches. So I can say, hey, what are the closest vectors to, to this vector, right? So I do a search with the one of the distance operators here. So there's various distance operators you can use. If you look at the pgvector repo, it talks about all the ones you can use. Oh, it's also listed on the pgvector Python repo. But let me go to the main repo for pgvector. And what we can see here is that we've got, this is the L2 distance, also known as a Euclidean distance. They've all got different names, so this is a distance operator. Now, the one that most people actually use these days is cosine distance. So that's probably the operator that you're going to want to use. Sometimes I use inner product, if depending on the kind of vectors I'm working with. So you've got 4 different distance operators that you can use here. And yeah, and then that gets it. So this is just showing an example with really, basic vectors. But what we're going to do in our actual, when we're doing RAG, is that we'll take the tables that are in our database, we'll take the rows in them. My system always wants to update when streaming. So we'll take, a row in our database, we'll make an embedding that represents that row, and then store that embedding. Okay, let's not do this right now. All right. So I have an example table where I've actually already computed the embedding. So here, let me look at my local table so you can see. And right. So, well, we could look at the table we just made. Right. So that's, that's what that table looks like. That's really basic. Now, what an actual table might look like is this one here. Right. So here you can see this is actually a table of videos from the YouTube VS Code channel. So this is like the titles and descriptions and YouTube IDs for each of those videos, right? So you can see, title, description, and then embedding. And so this embedding is an embedding that I computed using one of the OpenAI embedding models. And let's see, it is, let me see, how long is this field here? It's not listing it there, but it's either 1536 or 1024, I think. But it's, it's a fairly long vector, and these vectors, represent both the title and description, in this particular embedding space. So that's what it would look like, when actually using it. Okay. So let's see. We've seen how, we can add a vector column. We can add an index for more efficient searching. We can figure out which of the operators that we want to use. And then we can actually create a table that has vector embeddings. Now, this is one way that you could store embeddings in your table. Later, Joshua is going to show a way that you can do it using the Azure AI extensions for Postgres. But what I did here is that for each of the rows in my database, I made a call to the embedding model. So here I use the text embedding 3 small model from OpenAI, and I specified I wanted 256 dimensions. So I got back a vector with 256 numbers in it. And then I said, okay, update that row and set the embedding to, this list of numbers for that row. So this is one way that we could, process all the data in our database in order to update the embedding. Of course, when the data changes, we would want to update those embeddings as well. So you could have functions or triggers or cron jobs or anything like that in order to help you manage that. All right, so now let's see how we could do some more vector search with this. Okay, so going back to this example, so we saw that videos, that videos table here. So let's do some queries on this video table using, using all these fields we have here. So we've got title, description, embedding, and the ID. All right, so let's go to this query here. All right, so I'm doing the same thing here. I'm setting up the, the extension. So, I could do just a very basic select just to check all my videos. Okay. So now what I want to do is I want to do a vector search. All right. Now, in order to do a vector search, I do need an embedding. So in this case, I'm actually using the Azure AI Inference SDK. So this is an SDK that you can use to interact with a bunch of Azure AI models. So that includes GitHub, like OpenAI models, but it also includes like Mistral, Cohere, a bunch of different models, and it includes all the GitHub marketplace models. So I'm actually using a marketplace model here so that I can just do this for free in a code space. So if you haven't signed up for GitHub marketplace models yet, go ahead and sign up for it. There's a wait list now, but sign up early so that you can get on. So you can see here, I've got different embedding models I can use. So I can use this OpenAI text embedding model. So that's what I'm going to use. So I have to make sure that I compute the embedding for the user question using the same embedding model that I used when I stored them in the database table, right? So your embedding model always has to match, which means you need to remember what model you use, because every embedding model has different embedding spaces, right? They all have like different brains. So you do need to make sure you match. So you can see I'm using that text embedding 3 small model again. And so I had to get a question, right? So let's see, like, got any videos for someone who wants to learn Python? Okay, so maybe the user is asking that question, right? So I then turn that question into an embedding using this embeddings client and get back the list of numbers. And then I want to actually search for it. So what can I do to search for it, right? I can use code like this one. So we're going to do select, okay. Forgot that we can't copy and paste from PowerPoints. That's fine. Select ID. So I'll just select the ID from videos where the embedding, and we'll just grab it from the other one here. Yeah. All right, we're embedding. Okay. And then we'll pass in the embedding. All right. And then probably want an order by too, huh? Did I have an order by here? Yeah, order by. So we're gonna, so we're actually gonna select from, we're gonna order by that embedding distance, and then we're gonna limit. Yeah. So order by embedding, limit 20. Okay. All right, let's try that out here. Good old live programming. All right, great. It worked. So what you can see is that the very top result is effortless Python with GitHub Copilot. Then we have Python in VS Code. Then we've got Pylance, a viral thing, Python. So lots and lots of Python here. So the embedding model definitely saw that I was asking about Python and got back some stuff. Now, what about Postgres? Like, I don't even know. I feel like the only videos on the VS Code channel about Postgres are probably from me. We got to get Joshua on there more. But okay, what we see is there's one about dev containers. And they could be talking about Postgres in there. Because remember, this is looking at both the title and description. This is the one I did using Postgres inside dev containers. So it did find that one. Then we've got COBOL. I don't know exactly what COBOL has to do with Postgres, but maybe it does. You'd have to look at the whole video and the description, right? Yeah, so we got back some results, and we can see that, that's what we can get with a vector search. We could also try databases generally, right? And see, like, if somebody wants to learn databases, we get, can you build a website with nothing but an iPad, preparing for a tech interview, understanding linked lists, right? Linked lists are like a data structure. So it's really interesting because here we're searching. So this is what's interesting about vector search. Here I'm searching for things that they actually don't really have a lot about, right? The VS Code channel doesn't actually have a lot about Postgres or databases, right? And the thing about vector search is that vector search will always find results because there's always some vector that's closest to your input vector, even if it's actually really far away. So one thing you can look is look at the actual distance scores that come back, and you could set a threshold for things that come back if you get a feel for how close is close enough. But that is something to keep in mind. When you do a vector search, you are always going to get results. All right, so now let's look at being able to do a full text search, because it's saying best practice is if you can try to do both a a full text search and a and a vector search at the same time, right? So what I'm using here is actually the built-in full text search to that's part of Postgres, right? And it's called TS Vector. This is confusing. The built-in full text search is called TS Vector because it uses a vector-like way of representing the words and word frequency and stuff like that. But it's not using a vector embedding model the way we think of it. But it is called TS Vector, which is a bit of a confusing thing. So let's see. I'm just going to escape out of it so I can copy paste. So here we go. All right, so let's go ahead and let me try this full text search here. And then we'll pass in the question. Okay. All right, so now we've got a full text search query. So let's see what kind of results we get for a full text query. We got no results. So here's the thing, is that the Postgres full text search query support is not as it's not fully featured, right? There are better full text search options out there, Azure AI search has really good full text search. They use Lucene, there's like Elasticsearch and stuff like that. So it can work well for some things. It's not necessarily that great for this kind of thing here. Now, if I just search for PostgreSQL, then I should, well, yeah, I did get one result, which is probably also a video for me. What if we do Postgres instead of PostgreSQL? Because, you never know how we're going to write it. And there we go. This one, interesting. This one, Postgres, matched the one that says PostgreSQL in the title. Oh, maybe actually, we should check. Oh, I'm only searching the description in this one. Yeah. So that's why. So it was what was in the description. I could search the title and description, and that would be a better thing to do. But that's something to keep in mind with the Postgres full text search support. It can be useful, especially for finding really exact names and numbers and IDs. But it's certainly more limited than than other full text search options out there. Okay, so we've seen, full text. Now let's go to a hybrid search. What does a hybrid search look like? And this looks like, quite a big query. And I will admit, I totally got this query from the pgvector Python repo. It has this great examples folder, and it has a hybrid stitch folder. And you can see here that it has this example here. So definitely check out that pgvector repos, all of the repos, in order to find more examples, because they've got great examples. They've got great docs, right? So I can go ahead and, take this and, okay, so now I need to pass in several things. I need to pass in the embedding, the query, and K, which is a number that's used as part of the fusing algorithm. So I'm going to do query embedding K. Okay, great. And K we actually usually set as 60, just because it's the best number that people have found for this algorithm. Okay, and so this time I was searching for Postgres. I got Postgres as the first one. That's good. Then I got type safe database access. Okay, well, it's a database. Then I got MongoDB. So I think what we've concluded here, Joshua, is that we need to get you on the Visco channel more. So we'll have more Postgres results, because I think it did a pretty good job of actually finding what's there.
Agreed. Yeah. Well, we need to collab some more.
Yeah. And actually, you know what? I have a video coming out later this week on the Visco channel where I write RAG with Postgres from scratch. So pretty soon.
Awesome.
This data. That's why I actually have this this database, is the Visco channel got it for me for that. All right, so we've done a hybrid search. All right, so finally, let's do a RAG flow, because we said this whole thing is building up to a RAG flow, right? So I wanted to show some of the options we have for searching, right? You could do a straight vector search. You could do a straight full text search, but you probably don't want to, given its drawbacks. But you can also do this hybrid search option here. And one thing you might want to do is look at your answer quality, evaluate what search results you're getting, try different options and see what's working for you. Look at the performance, the latency, and decide, is it worth it to do both kinds of searches, or do you just want to stick with just vector, right? It's going to depend on the kind of user questions you have and your original data source. All right, so let's do a RAG. All right, so I'm setting up my Postgres database again. Let's see, let me do a new question, how do I use Postgres inside VS Code? All right. Turn the question into an embedding. So we get back that embedding vector. Then we have that hybrid search that we just saw. Then we fetch all the results. We grab the full information for each of those. We format the results in a way that's nice for the LLM. So here I just kind of put the title and the description with some new lines and some markdown. Then finally, we are sending the request to the LLM. So in the system message, I say you must answer according to the sources. Say you don't know if you can't find the answer in the sources. Cite the title of each video inside square brackets. The title of each video will be a markdown heading. So I'm describing what the sources look like and how I want citations. And this is a really common thing to have in a RAG system message. Then I send in the user question plus the sources. to the LLM. I'm sending it to GPT-4o, which is a pretty good LLM. I'm setting a temperature about 0.3, which I found to be pretty good for RAG. We don't want it to be too creative, but we also want to give it a little bit of flexibility. I'm setting the max tokens to 1,000 so that it won't get too lengthy in its response. And then there's top P1. I'm going to drop that because I usually don't mess with top P. Okay. So there we go. We've got it. And I'm going to go ahead and send this request. All right. So here you can see the results. So I just printed out the results just so we could see what it got back. And then it says to use Postgres inside VS Code, you can leverage dev containers and GitHub code spaces. So it says set up a dev container, install the necessary extensions. And, it didn't tell me exactly how to include the Postgres service, but this is basically correct. And I'm guessing it was from my, there you go. This was based off the video. And this was just from basically from this was probably a combination of what it found in the video description and what it already had in its weights. That would be my guess, right? Generally, that's what happens when we do RAG, is that we both get, answers that are grounded in what we actually sent to it, and it might have just existing information already in its training data, right? Like it already knows a lot about VS Code. It's seen a lot about that. So it can kind of combine that information together in order to come up with a nice answer. All right, so that is a basic RAG on Postgres, and I will, I'm gonna, push this, just make a branch for this one and push the branch, and I will share it in our GitHub discussion thread for this RAG hack session. So you can just check that after to find everything, demo stuff, and there you go. All right, I'll push that after. Now, going back to the to the presentation here. So now let's look at a full RAG with Postgres solution. All right, one that does a little more end-to-end. So this is from an open source repo that you can check out yourself, clone, and deploy. It's aka.ms/rag-postgres, and we'll put that in the chat so that you can start cloning it and starting it today. It is a RAG with Postgres solution that can work entirely locally, and then also can be deployed entirely to Azure. Let's see. Let's check out the demo of it. All right. Well, that's the code. I want to look at how. Let's actually just bring up the demo for it. Okay. So Okay. So here we go. Here's the deployed demo, and I also even have it working locally too. Here we go. All right. So RAG on Postgres. Okay, so this is a RAG which is asking questions about a store that has outdoor products, right? So they've got shoes and backpacks and that sort of thing. So we can ask a question like best shoe for hiking. And you can see the response streams in. You can see a citation, and the citation, references the row of the table that it came from. So we can click on that and then, actually see that, okay, it searched the database for this information and then sent it and got back the response. So that's what we saw before. Now, actually, this did what I call an advanced RAG. So if we go back here, right? So we got the user question, and we actually first send it to an LLM to do a query rewriting. So we say, hey, LLM, here's the user's question. Could you please rewrite it, right? And then we take the rewritten query and we use that to search. So if we go back to this, you can actually see there's a first step, and that's this first step. This is the LLM rewriting step. And this is really helpful to have as part of your RAG flow. So we say, okay, here's the user's question. Can you please turn it into a good query? And in this case, it actually didn't do much. It didn't do any transformation at all, really. It just dropped that question mark. But let's try that one. Like, what's a good shoe for a mountain trail hike? Okay. So here I've got a spelling mistake. I've got a lot of unnecessary words, right? So we'll take a look at it and see what it did. So this time it took that user question and it turned it into mountain trail hike shoe. So now I'm using that query, mountain trail hike shoe, as my query for both the vector search and the full text search, right? So I also think this is particularly helpful if you are trying to do the, the keyword search as well, in that, you're probably going to get better results because we've gotten rid of all this kind of unnecessary cruft that the user wrote, and we've really narrowed it down to what is the important thing that needs to be searched for. So that's one benefit of the query rewriting phase. Let me show you one more thing we can do with it. So here I ask, do you have climbing gear cheaper than $30? And we get back a response that says, oh, there's a chalk bag that's only $21.99. So great, that's the correct response. Now, what happens this time is that in the query rewriting phase, it also suggests a SQL filter that I can apply to the price column. So it says, hey, we think you should search for climbing gear and then also do a filter of price less than 30. So I actually apply that filter so that the SQL query does that filtering down first and then does the vector and hybrid search on with just the climbing gear query. So that way we make sure the results we get back are definitely less than 30 and that we only send results to the LLM that are less than 30. So this is really helpful to do, is if you can, we really are just trying to get the best results possible, right? So sometimes that means, coming up with, more advanced filters in order to figure out what exactly we should be searching for, and filtering on metadata in addition to the title and description columns, right? So I also have filters for other columns as well, like type and brand and stuff like that. So you can potentially have it suggest all sorts of, different things in that query rewriting phase. It's a very powerful phase to have as part of a RAG flow. So we get that back. All right. And so we saw that example there. And the way this works is that I'm using an LLM that has function calling. So function calling is a way to get more precise results from an LLM, right? So here the LLM is literally responding back with this function call here. It's saying, hey, you should call this search database function and you should pass in this query and you should also use these filters here, right? So it is telling me all that information. So I just directly can take that and say, okay, I'm going to use climbing gear as the search, and I'm going to use this as the filter. So it's a great way of being able to get really precise, structured information from an LLM that then, we can use to build up a nice SQL query. And so then you can see, what does the actual flow look like? Well, first we get the user question, then we send it to the LLM. The LLM will suggest, the search query to use, as well as any additional SQL filters. We use that to search the database table and then send those results to the LLM. And this is a general code walkthrough. So if you do want to dig into it, this shows you what the code looks like. But basically, we've got a JavaScript front end with React, and then we have a Python backend, which has it's a fast API application, and it has both a simple RAG and advanced RAG file, and they step through those steps we saw in the diagram. You can also deploy this pretty easily using the Azure Developer CLI, and you can follow the instructions in the README, but this is basically what it says, is that you're going to log in and you're going to run AZD up, and that will deploy everything to Azure so that it's working on Azure. So you'll have an Azure container app, which is actually serving up, the actual web app. And then that makes call to an Azure database for PostgreSQL Flexible Server, and also makes call to Azure OpenAI. And it used keyless authentication for both of them. So it actually is using managed identity to authenticate to the Postgres server and managed identity to associate to authenticate to OpenAI. So there are no keys involved in this app at all, and no passwords, which I was really happy to have happen because it's much better from a security perspective. So there you go. So that's one of our RAG on Postgres templates that you can get started with if you are interested. And that one can also run entirely locally using a local Postgres and a local model from Olama. So that's another option, is that if you're trying to get started with RAG, but don't have the funds to start deploying to Azure, then you can also get started locally too. Cool. So that is all I'm going to show. And now I'm going to switch over to Joshua to talk about AI extensions.
Awesome. Thanks, Pamela. I really appreciate that. And it's nice to see the app running without keys. That's been a downfall for some of these for quite a while, right? So let's jump into the AI extensions for Postgres. So Postgres is an extensible database, right? We have tons of extensions for it out there in the community. We also have, a huge list of extensions that we support on Azure Database for Postgres, right? Under the covers, we're still open source Postgres. We want to be that way, right? We commit back to the open source community, quite a bit all the way through the upcoming PG17 that's rolling out. So for us, first off, the vector data type. Vectors are just a data type to us. That's why we have native vector support. Allows you to do, column level or row level security and all those things, right, that you would expect from an enterprise database, and have that on your vectors as well. And then, with that comes, vector indexing. Pamela talked about HNSW. HNSW is a great option today because it'll allow you can build that, or actually you define that index on an empty table. Empty columns doesn't matter, right? You don't have to set up probes and lists like you do with other types like IVF flat, and it will just build that index as you load data into the table. So it's pretty fun in terms of that, right? As you can just keep rolling. Also handles inserts, updates, and deletes fairly well, right? So that you don't have to do index rebuilds. So where we really differentiate ourselves, right, are with our specific AI extensions, right? So the first one, the Azure AI extension, that opens a SQL interface to Azure OpenAI, Azure ML. If you use the ML catalog, right, or if you want to bring your own model and use those models, right, deploy it into the ML catalog and call that endpoint via function call, right? So you never have to leave your SQL command, right, if you don't want to. Allows you to create embeddings from a SQL statement. We'll look at the syntax of that. And then also opens the door to all the Azure AI services, formerly Azure Cognitive Services, right? If you still look at the code underneath, when you're calling those APIs, it's Azure Cognitive. But that includes language services, sentiment analysis, text summarization and abstraction, all of that. So very, very powerful with basically just allowing you to call these endpoints and you're off and running. And then other integrations, right? We do play well with others in terms of the open source community with LangChain, Semantic Kernel, and Llama Index. LangChain, the official documentation was originally was recently updated to actually list us as Azure Database for Postgres under the Microsoft services. Previously, you had to go to the Postgres offering, and anything they say there is going to work with me, right? But now we're out there as officially. So, just kind of what does this look like, right? It's the Azure AI extension, right? Super simple out of the box, right? Because everybody's being asked to add AI to their applications, and we wanted to make that as simple as possible, right? If you're new to this world, which is just taking everybody by storm, right? How do you quickly add some value to your application in terms of all the different AI services that are out there? And so we allow you to do that with an extension and some function calls. And so what does that look like? So for vector generation, we have two options, right? You can do your remote embedding model, right, which is similar to what you do from a LangChain call to OpenAI or Azure OpenAI or any of those, right? We can do the same thing, right? Text embedding Ada 2 is listed there. My newer embeddings are done with text embedding 3. And essentially the application would call into Postgres and then call the OpenAI embedding model and then get that embedding back. Now, the embedding, like Pamela said, that's just a floating point set of numbers, right? For OpenAI models, the standard is 1536 dimensions, right? But you can go down, right? But yeah, so just depending on your testing and what makes the most sense for you in terms of recall and accuracy, right? Like, do you really need a 1536 embedding and which is 6 KB per row, right? When you start generating those indexes and generating those vector embeddings. So for some folks, they want to test with a smaller dimension. So to that end, we actually have a unique offering, right, for in-database embedding. And currently in preview, we announced it at Build, and that is the Azure Local AI extension. So that is unique to us. We actually deploy the multilingual E5 small model into a container in the same VM that's running your Azure Database for Postgres instance. So this works with any of the memory optimized offerings, 4 cores and up, and we carve out a small 2 gig container on that same VM, and we'll deploy that model for you. Which that runs with 384 dimensions. So roughly 2 KB, right? Like we can sit and do the napkin math on that in terms of size. But very, very fast in terms of generating the embeddings because you're not making that remote call. So we really drop the latency down on that. And as you can see here, like this is based on our internal testing and definitely reproducible, right? In terms of basically an average in terms of milliseconds, you're hitting about 77 milliseconds, right? For remote embeddings, and 7 milliseconds for in database. So much faster to generate those, and for your use cases where you don't want your data ever leaving your database environment, right? You don't want it leaving that. That's something that's definitely worth looking at. Also, cost predictability, right? You're not running any additional endpoints, right? You don't have to guess how many tokens you're going to use. You don't have to know anything about that, right? It's just going to use the VM that you're already paying for, right? So, and let's take a look. I think we've got a couple of RAG pattern diagrams here, but as far as this one goes, we're gonna take a question, right? Like we've got an employee who's looking to see what does their insurance cover, right? Does my insurance cover LASIK, right? And this is something that really you should have it grounded in your actual documentation, right? But what would happen if you didn't, right? So let's go out to any model and ask it that question, right? And of course, there's no RAG. It comes back. LASIK is not typically considered medically necessary, and most of them won't cover it. And that's actually an answer from a GPT model. I didn't make that up. I asked it the question and put it in here. So it came back with no, but let's actually do it the right way, right? As far as I'm concerned, let's create an embedding. We'll do a similarity search from that prompt. It's going to get some context, right? It's going to see from our now this isn't our actual insurance documentation. We did get an example of one since we're streaming this, be sure, but it's gonna get the proper context. And then it's going to answer the answer, and it says your insurance covers LASIK with some stipulations, right? So better answer, right? Than the flat out no, and then we could go back and forth with it. What are those stipulations, right? So definitely love those examples because we used an LLM to really generate them. So see what you might get back. Now, for this next example, this is the other one that was shared. I think the links already went out as far as the eShop on Azure, which we ported over to Azure DB for Postgres. This is .NET centric, right? It's using semantic kernel, Azure OpenAI, and Azure Database for Postgres. We're only using the pgvector and Azure AI extensions for this example. A lot going on in this architecture. right? But essentially, any modern application architecture, right, you're going to have things split up into different services, right? Your identity service and catalog service, order services here, basket, and for this one, especially the catalog service, and we've taken this catalog for this adventure company, right? This is actually a winter outdoor gear company and we've generated our vectors from that catalog and the descriptions and all of that. And so this one it's quite a large set of services. So when you jump into that, you load that into VS Code, don't get concerned. It's relatively easy to go through and change it up, change the prompt, give the chatbot a different personality if you'd like, right? It's just a little paragraph giving them their personality. So let's take a look at this actually up and running. So what I'm going to do, I've jumped into the website and I'm going to start a chat with the chatbot. I'm going to say, what jackets would you recommend to a new snowboarder, right? I'm in the Pacific Northwest. I'm a newbie. Tell me what you've got, right? So get a couple of nice AI generated images that we stored as well. And then I can ask it, is it in stock, right? And it keeps my chat history, right? So it's gonna understand the context from the chat, and it's also gonna check my catalog API and the catalog and see if it's in stock. And I'm gonna ask it to add it to my cart, but it can't do that. It doesn't know who I am, because I don't want folks to just add a bunch of stuff to their cart and then run off, right? I want to be able to know who they are, and then I can send them an email going, "Hey, that thing you left in your cart, it's still there." Little nudges, right? Things like that. So now I'm logged in, and it's got me logged in. Actually, this works with AAD now, intra ID rather. I should get used to saying that. And so, what gear would you recommend for a new snowboarder? A little bit different question, and it actually gives me a list of things that I should go get. So first, let's start with a snowboard, right? Let's see. And what snowboard's best for a beginner? And then I get a few options back, and I'll ask him if it's in stock. And ask it to add it to my cart.
Is this also, this probably isn't doing it yet, but this makes me want to do a multimodal search with image embeddings, because you do have those images, right? I assume it's not doing that yet, but it could.
This is not doing that yet. These embeddings are the descriptions. So like the name of the item and the description of it. But yeah, no, it would be really fun to build off of this one and add in the multimodal models.
Yeah. Then you could be like, oh, I need a bright orange jacket, or I need like a really gaudy looking jacket.
Yeah, it'd be interesting on some of these, like as far as they go back, like depending on how detailed the description was, right? It may actually find answers for that.
That's true. Yeah. So sometimes you find that
cart
in the description, but if we're for like I was on a product search site the other day, and I was looking for volcano t-shirts, and they didn't have a description of which of their shirts had volcanoes on them. This is for my 5-year-old. And I was like really upset, because I'm like, how am I supposed to find shirts with volcanoes, right? That's the sort of thing that in like a multimodal model would totally know if there was a volcano on a shirt.
Yeah, that would be really fun. But yeah. And yeah, sorry, I've let it go ahead and skip to the next slide, but this is just showing that it was out there running, and all the different services got created. We didn't go into the weeds of you know, all the things that happen when you AZD to get it up and everything, as far as, you know, sorry, AZD for Azure Deploy from VS Code to then deploy it directly to my resource group for me. So I don't have to go out and do all of these things one by one, right? Previously, it was running on containers, you know, Docker on my machine and all of that with Postgres and all, and then send it up. So yeah, awesome. And then now this isn't technically RAG, right? Like it would be, right, if I had an app to put it in, right? But as far as showing some of the other features, right, that you get from the AI extension, right? Being able to do, you know, that hybrid search, right, that you were showing off before, and then, you know, let's this is built off of an older Airbnb data set, right, just an open data set for Seattle, and looking at combining semantic similarity search, vector search, right, geospatial data. So I did have to enable one additional extension, PostGIS, which is available and fully supported by Azure Database for PostgreSQL Flexible Server. And then I'm going to call the Azure AI services. And so with this one, before I kick it off, just kind of looking at the query itself, right? I'm setting the geographical point, right? So the latitude and longitude point, right, for the Space Needle, right? And then in my data set, I've already added the all the GIS data for all the different listings. There were a little over 2,000 listings in this data set. And then I'm going to use multilingual E5 small. I'm going to combine my small embedded model, and then I'm going to also call the external services, right, or the Azure AI services. So I'll kick this off. And it's going to take that prompt, and it's going to generate an embedding from that search, right? So the properties in Seattle near the Space Needle with 3 bedrooms that allow pets. Quite a mouthful, right? I asked actually somebody I asked for input for some of those queries, right? Because I'm too close to it, and so that was one of the wordier ones I got back, and so we wanted to see how well this would work. And as you can see, it actually it came through, and it also did the translation service. I didn't even talk about that, right? As how it was going to go out to the Azure AI language service, and is going to translate for me as well. And you set that up just based off the 2-digit code for language, supports over 100 languages. And also that multilingual E5 small embedding model supports 100 languages as well. So it was a cool combination of the two. And then thanks to the PostGIS extension and pgadmin, I can put a map up on the screen and actually see the results, see how close they were to Seattle Center and the Space Needle, and see the summary in the original text, and then the translation. So very quick example of how you can add all of these features, right, with just a little bit of SQL. Awesome. And that concludes my really quick demos. I was trying to come in under time, so if we had questions, we were good.
All right, so thank you, Joshua. There is one question specific to Azure that I attempted to answer, which is just, you know, pricing. Can you deploy Azure Postgres for free?
Yep. So there is a I'll drop the link into the studio chat so it can get thrown in there. There is a way to go and deploy Postgres for free, just like you can with a lot of other services, right? When you go through and sign up for a trial account, right, with Azure, and we're listed in that list of services that are available.
So if you are new to Azure, it's an option, right? If you have a
Yes.
new
Yeah.
Azure account. Yeah, I think I use that because I have a personal website that's running on Postgres,
hmm
and I use that free Postgres server for the first year. I think for the first year, right? And then it becomes a paid server, right?
Yes.
Yeah.
Yeah. It'll become paid after that.
And that now it's about, for me, it's about like $12 a month. It depends like on region and SKU and stuff like that. But once it does become paid, that was about how much it's costing me for the website I run on Azure Postgres.
Got it.
Cool. So that was the only question that we had that's unanswered. So if you're watching this and you have any other follow-up questions, do post it in our GitHub discussion thread that is just for this session. We'll be watching that to see any follow-ups you have. So it just got posted in the chat there. That's also where we'll post slides, recording. I already updated it with the code that I showed. So that's going to be where we put everything. As a reminder for RagHack, if you're submitting to RagHack, there is a prize specific for Postgres, best of Postgres. So I do recommend, submitting for that prize and using Postgres and showing what you can do with all the cool features of Postgres and the extensions. And yeah, it's really fun to see all the combinations. I think Postgres is now the most popular database in the world, right? Because the
2 years in a row.
2 years in a row. With the
2 years in a row
survey.
from Stack Overflow, and consistently in the top 5 in DB engines as well. As an engine, right? As a database engine. I'm not saying our offering is, but
right. Yeah, just Postgres.
Yeah.
Generally, I think Postgres generally just has a nice developer experience, and it has these cool extensions like pgvector and PostGIS. So for me, it's personally my new favorite SQL database. As a child, of course, I used MySQL, as like a 12-year-old or whatever, but I've moved on, and now I like Postgres. In the chat, we have Postgres for the win. Exactly.
Yeah, love it.
All right. Well, thank you everyone for watching. Thank you so much, Joshua, for sharing all your Azure Postgres expertise, and we look forward to seeing your RAG hacks. Bye, everyone.
Awesome. Bye, everyone. Thank you.
Hey, everyone. Hope you enjoyed today's session. If you aren't registered yet for RagHack, you can register now at akka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thanks again for joining. Thanks to both of our speakers. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 23331. We'll see you at the next one.